Hello pre-calculus, I'm back with the second lesson of the chapter. We're doing a graphing exponential functions part 2 deal with this. So hopefully you guys successfully plugged it into the table functions of your calculator. You could figure out the horizontal asymptotes, the domain, the range. You got your table of 5 values, and the graph has been produced. Now, what I wanted to extend this lesson towards is this. Remember vertex form? A times x minus h squared plus k, and how that pretty much permeated every single type of graph we could come up with. You had your parabola, you had your square root function, you had your absolute value function, which pretty much follows those same guidelines. Heck, you even figured out how to get your linear equation functions to kind of do the same thing. Remember? X minus h plus k with your m on the outside? I didn't forget about that. Here's the deal. And I could probably come up with a slew of others here. These exponential functions work the exact same way. Y equals, and you know what? This 2 can be any number. I'm just going to put a 2 so that we're not confused. 2 to the x minus h plus k. And from there you guys can see, oh, if it's affecting the exponent, we're going to have a lot of similarities between these two, right? Because when you had a negative root x, this was a vertical reflection. It flips it over that way. Same thing here. Negative 2 to the x is also going to be a vertical reflection. If you have it on the inside, negative x, that is a horizontal reflection. If it's 2 to the negative x, additionally, that's going to be a horizontal reflection too. And then just the whole idea of minus h means shift right, plus h means shift left, plus k means shift up, minus k means shift down. Okay, so right now, I feel like I'm not going in a great direction. I'm just throwing a bunch of stuff at you. Let's make our table of 5 values and get moving on this one. So normally, you guys would have x, y, and you'd go negative 2, negative 1, 0, 1, 2. Here's the thing though. This right here means that you're shifting everything horizontally left 2 units. All right? So the x-axis is the horizontal axis. So what you're going to do is you're going to subtract 2 from each of these to get points that matter on the graph, okay? So negative 2 minus 2 is negative 4. Negative 1 minus 2, negative 3. So those are the appropriate x values to check. Those are the appropriate x values to plot points with. If you're shifting horizontally, you want your table to reflect that. So, okay, sorry, I had a little momentary lapse. I think it was because I was going to make a pun about reflections, how this should reflect that, but then my brain was like, no puns right now. Get through the video. So if I go through to the table function, I'm gonna plug this in as is. So negative 2 to the x power, x plus 2. Make sure the x plus 2 is the entire exponent. And then make sure the plus 5 is no longer in the exponent. All right, so your table should show you that negative 4 yields 4.75. Negative 3 yields 4.5. So plotting our points, left 1, 2, 3, 4, up 1, 2, 3, 4.75. Left 3, up 1, 2, 3, 4.5. Left 2, up 4. Left 1, up, oh, that's not 4. Left 2, up 4. Left 1, up 3, 0, 1. Oh, we have a horizontal asymptote at the plus 5 here. So we should make our dashed line to be very clear to our reader that there is a leveling off point right up here. And then it is not going to go above it. It's going to get super close, but never cross. And then it's going to take a nosedive real quick. 1 goes to -3, 2 goes to -11. So, wow. Okay, we've got our graph. We've got our horizontal asymptote. We've got our table of 5 values. What's the domain and range? Well, I'm glad you asked. The domain, again, we talked about all real numbers being the domain of any exponential function. The fact that it shifted left 2 does not change that fact. Every single x value from -infinity through infinity, every one of them is going to have a y value that it corresponds to. So it's still all real numbers. How about the range? Well, that's a different story. Your ceiling is 5. You can go all the way down to -infinity. So you start at -infinity, go up to 5. Do not include it because it's never actually touching the horizontal asymptote. Okay. Number 1 done. By the way, let me just see how many we got here. Oh, we got a few. All right, let's accelerate this. So ask yourselves these questions. One, should I change my regular intervals of x equals -2, -1, 0, 1, 2? Am I adding to or subtracting from those amounts? Answer, no. There's no horizontal shift going on. No horizontal shift. But there's a horizontal reflection because of that negative right there. This creates a horizontal reflection. So we should just expect to see sort of an opposite pattern that we normally would. Do we have our asymptotes down? The plus 1, yes, there's going to be 1 at y equals 1. Domain and range, I think I'll graph it before I start making decisions about that. So let's check out our chart, get a table of values going. So it's 3 to the -x plus 1. Start at -2. Looks like, oh my goodness, -2 gives me 10. Wow. Well, it's going to be, here's 8, 9, 10. We'll just say that this is about 10. How about -1? All right, bringing us back to reality. 1, 2, 3, 4. We're back on the grid. 0, 2. 1, 1.3 repeating. That's just 1 1/3. 2 gives us 1.1 repeating, which is 1 1/9. Oh shoot, I haven't even been putting these in here. I'm sorry. And this gets infinitesimally smaller. Oh boy. So it levels out, never going below that axis, which tells us that our domain, or I'm sorry, our range is going to be from 1 to infinity. That's our y values. our domain is going to be all real numbers. All right, so hopefully you guys are getting super comfy with these. Hopefully there's not extreme frustration happening. All right, so now, I'm going to do a little rearranging here. Much like, can you guys see this here? Yeah, you can. If you had 1 minus x inside the root, you would have to take the negative out of both parts to really get the whole story. Oh, this is shifted right 1, but reflected horizontally. Well, you got to do the same thing here. This is shifted right 1, but reflected horizontally. Now, that doesn't affect our horizontal asymptote. We still have one at y equals negative 1. But it does have kind of an effect on our table of values. So we would normally have, horizontal asymptote at y equals negative 1. You got that piece of information. So negative 2, negative 1, 0, 1, 2. Are we going to change these x coordinates? Yeah, we're going to change them because it's shifting right 1 and it's reflecting that way. Well, let me think about this, because sometimes the reflection, what it does is it says, it doesn't matter here. Okay, it's not going to matter here, but once we start talking about logs, it's going to get a little more complicated. Anyway, just add 1, add 1, add 1. That's going to give our new x coordinates, which better reflect the actual important parts of this graph. By the way, when you plug this into your calculator, I would just encourage you guys to plug in the original, because it's usually the simplest version of it. Plugging in this opens you up to a lot of errors. Let's just use this one. 2 caret to the 1 minus x power, bring it back down, minus 1. All right, so we got negative 1 corresponding to 3. 0, 1. 1, 0, 2, negative 1 half, and 3, negative 3 fourths. Yeah, it seems to fit the bill. We're getting infinitely closer to negative 1, but never going past. So 1, 2, 3, negative 3 quarters, 1, 2, negative a half, 1, 0, 0, 1, negative 1, 3. And then you can fill in the gaps by plugging in some more points. Like in this case, negative 2. What's that give me? 7. Why not? Okay. I know this is getting super tiresome to say the domain is all real numbers every single time. But I'm just really hammering home that these exponential functions have no x value restrictions to them. No domain restriction to purely exponential functions. However, the range, I don't think we found one case where the range is all real numbers. The range is basement valued at negative 1. Can't go lower than that. No ceiling, though. All right. So, that's the gist of it today. Can you graph when you have vertical and horizontal reflections and vertical and horizontal shifts? Now, the last thing I wanted to talk about is kind of what you saw in the graphing sense chapter. Can you build a function if I give you certain characteristics for that function? The answer is, after you watch this video, yes. So create an exponential function that's reflected horizontally. So that's like negative x in the exponent, right? Has a horizontal asymptote at -2, which means the whole thing's subtracting 2, and is shifted 2 units to the left. So that's where we would have to put in parentheses plus 2. Yeah, and it's, if I say base 2, that means that the exponent is, that the big number is 2. So it's going to be 2 to the negative, horizontal reflection, x plus 2, shifted 2 units to the left, and then the -2 is the horizontal asymptote at y equals -2. If it's a function, maybe I'll just call it f of x, and there's your answer. So we're just building a function using our understanding of how the structure of the equation yields both shifts up and down, shifts left and right, and reflections both vertical and horizontal. All right, last one. Our video is topping 16 minutes and 30 seconds. Let's conclude this thing. All right, so this one's got base 2 as well. So it's f of x equals base 2. Reflected vertically, that means we put a subtraction symbol out front. Shifted 3 units to the right, that would mean x minus 3 in the exponent. And then shifted 2 units up, add 2. All right, hey, thanks for watching. I hope you guys found this to be just a nice extension of what you've already studied in the Graphing Sense chapter. All right, if you get any calculator issues, but you know what, if you have any issues, just email me and I'll try to get back to you as soon as is practical.